Parallel lines. In a Cartesian plane, two lines with the same slope are parallel. Now remember, when we're talking parallel, it means that they will never ever touch. Ever. And we use the symbol of these like half arrows. Now if you see segment AB, the symbol is parallel as this. It's parallel to CD. This sign right here means parallel. It's also giving you the answer because parallel lines will never ever touch. So if they never are touching, they should probably have the same slope. So anytime you're asked to find a line that's parallel to another, they always have the same slope. So the linear equation y is equal to negative 5x minus 7 and linear equation 10x plus 2y minus 12 are parallel because their slope is the same. Well, let's prove this. So we know that the first equation is in y equals ax plus b. It's in function form. So the slope of line 1, we're going to call this line 1, is negative 5x. So we want to find out what the slope of line 2 is. So in order to do that, we need to convert 10x plus 2y minus 12 into y equals ax plus b form. So y is positive, so we're going to leave him positive, and we're going to subtract 10x from either side, and we're also going to add 12 to each side. So I get an answer of 2y is equal to negative 10x plus 12. I want 1y, so I'm going to divide each side by 2. So I get y is equal to negative 5x, because if I reduce negative 10 over 2, it gives me negative 5x plus 6. And if you look here, it has the exact same slope. So they are, in fact, parallel. And if I wanted to graph these, first line, so line 1, I'll make line 1 in red. I start at negative 7 because that's my y-intercept. 1, 2, 3, 4, 5. So negative 7. And I'm going to go down 5 and over 1. Okay, well, actually, I'm going to go up 5 since it'll go off the graph. So it's a negative slope. So it's going to look like this. So that's line 1. Line 2 I'll do in blue. So line 2 starts at 6 and we go down 5 and over 1. Down 5 and over 1. And there's my line. And as you can see, because they have the same slope, they will never ever touch. So that is, and these are what we call non-coinciding parallel lines. They are non-coinciding because they have different y-intercepts. Okay, so at the bottom of your page, I want you to make a note of this. Coinciding or coincidental, coinciding parallel lines. I'm using the symbol for parallel. Coinciding parallel lines have the same slope and same y-intercept. So it's basically, they are the same line on top of each other. Okay? And non-coinciding parallel lines have the same slope but different y-intercepts. So the graph above is an example of non-coinciding. If I had a coinciding parallel line, look at line 1, there would be line 3 and it would be going exactly on top. So it would be the exact same line there, coinciding. Now let's talk about perpendicular lines. Some of you guys had quite a bit of trouble with this, understanding this, so we're going to review. So in a Cartesian plane, two lines with slopes that are negative reciprocals. So a negative reciprocal, let's do a couple of examples here. A negative reciprocal, so if we look at a number, so we have negative 5. The negative reciprocal of this, if I multiply it, will give me an answer of negative 1. Now, negative 5 is like saying negative 5 over 1. A negative reciprocal of this is 1. You flip it, 1 over 5, and you take away the negative sign. And this makes sense because, for example, if I erase this for 1 minute, let's say I had an equation where the slope was negative 2x. Okay? If I have a slope that's y is equal to negative 2x, I'm going down 2 and over 1. Down 2 over 1. Down 2 over 1. So my slope is doing this. So this is line 1. Now, I want to find out what the equation of the perpendicular line is. Well, if it's perpendicular, I'm going to give its negative reciprocal. Its negative reciprocal is 1 over 2, and I want you to look. If it's 1 over 2x, which is the slope, I'm going up 1 and over 2. Up 1 over 2. It's doing this. Perpendicular means that you get that 90-degree angle where those lines meet. So in order for this to happen, you need to have a positive slope and a negative slope, always. Okay, so if I do negative 2 times 1 over 2, my answer is always going to give me negative 1. If that is how you make sure that it is in fact a negative reciprocal, if you haven't messed up. Okay, that's your check, and I would suggest most of you do it. So let's do another example. Let's check another one of our negative reciprocal exercises. So if I have, for example, if I have 1 over 3, the negative reciprocal is that you would flip it, so it becomes 3 over 1, and because one of them needs to be negative, and it's not the first one because it's positive, you make this one negative. If I put that in my calculator, I will get an answer of negative 1. If I have negative 2 over 4. So as we continue here, if I have negative 2 over 5, the negative reciprocal is that I'm going to flip it. So it becomes 5 over 2, and there's already a negative there, so I don't need to add one. I always have a negative, I always have a positive slope. And if I multiply that, I'm going to get an answer of negative 1. So that is a negative reciprocal. So, in a Cartesian plane, when two lines with slopes that are negative reciprocals of each other are perpendicular, when this is the case, the product of the slopes is equal to negative 1, which is how you check, you multiply. So let's do an example. So, y is equal to negative 1 over 3x plus 9. That's the first line. And linear equation and equation 3x plus 1 are perpendicular because the slope of one line is the negative reciprocal of the slope of the other. So we are going to verify that. The slope of line 1 is negative 1 over 3, and the slope of line 2 is 3. So if we multiply negative 1 over 3 times 3, we're going to get an answer of negative 1, and that works. So these are in fact negative reciprocals of each other, and if I were to graph this, start here. I'm going down 1 and over 3. 1, 2, 3. Down 1 over 3. Down 1 over 3. So this is my line 1. And then my line 2 is going to have a positive slope. So I'm going up 3, 1, 2, 3, and over 1, starting at 1. 1, 2, 3, 1. So it's going through the line like this. And there's my 90-degree angle, and that's line 2. So these are perpendicular lines. So let's look at an example. Line A, y is equal to 2x plus 11, and line B passes through 6 and negative 7. Lines A and B are perpendicular. Determine the equation of line B. This is a typical question that you would see on a test. So the first thing that you need to figure out is, okay, line A, they're perpendicular. So line A has a slope of 2. Line B, if they're perpendicular, its slope is going to be the negative reciprocal. So I see that this is a positive slope, so my other slope, my line B slope is going to be negative, and I'm going to flip, so it becomes 1 over 2. Now I want to check. 2 times negative 1 over 2 gives me an answer of negative 1, so that works. So now I have my slope. Now remember, when you find a rule, all you need is the slope and a point, so I have my point for point B. So y is equal to negative 1 over 2x plus b. I'm going to take that point, and I'm going to substitute it in. So negative 7 is equal to negative 1/2 times 6 plus b. Negative 7 is equal to negative 3 plus b. I'm going to move that 3 to the other side. So b is equal to negative 4. So my entire equation of this new line for line B, so the line B equation, I'm just going to write it up here in green, is y is equal to negative 1 over 2x minus 4. And if you were to graph that, you would get a positive slope and a negative slope and a 90-degree angle in between where they cross. So that is those are perpendicular lines. The next 2 pages in your notes booklet, parallel and perpendicular lines continued, as well as intercepts of the linear function. So the next 2 pages are yours to do as for examples.